Hello friends, today we are going to discuss something about normal distribution. The continuous probability distribution having a probability function f of x given by f of x is equal to 1 divided by sigma root 2 pi into e power minus of x minus mu whole square divided by 2 sigma square, where x lies between minus infinity to infinity, mu lies between minus infinity to infinity, and sigma greater than 0 is known as the normal distribution. The mean of the normal distribution is mu and variance is sigma squared. Friends, the graph of the probability density function in normal distribution is of the shape bell-shaped curve as I'm showing here, this one. And this represents the entire probability. Here you can see the line x is equal to mu divides the total area under the given constraint, which is equal to 1, into two equal parts. This is very important thing. The area of the right hand side as well as the left hand side of the line x is equal to mu is 0.5, which we can see in this graph. See, this is the left hand side of x is equal to mu and this is 0.5, and this is right hand side of x is equal to mu, again this is 0.5. So total area it's 1 and it exactly divided by half. And if you take some important note of this normal distribution, which will be useful for us to solve the problem, first we have to understand the standard normal variate. In short, we can call it as SNV. That z is equal to x minus mu divided by sigma. And the second note, if you take already from the figure we have taken, p of minus infinity less than or equal to z less than or equal to infinity is equal to 1, means the exactly if you take a graph like this, and if it is f of z or phi of z, if you take, and this is your this one is if you take this is z, then if you take a bell-shaped curve like this, so this will be from here, it is minus infinity to 0, this will be 0.5 that we have taken, and from 0 to 1 infinity also the 0.5 together from here to here, if you take, it will be 1. Okay, and also if you take p of z less than z1, then we can write that as 0.5 plus phi of z1, and if it is greater than z1 or z2, then it can be written as 0.5 minus phi of z2. And when it comes to the problems, see, evaluate the following probabilities with the help of normal probability tables that given. Now what we have to do here, p of z greater than 0.85, that we have to calculate. Now to calculate this, to understand the concept easily, that you can take a bell-shaped curve as shown in the figure. Okay, now what exactly, say this is phi of z as already we have taken, and this is z. Okay, now what we have to calculate, we have to calculate z greater than 0.85. So somewhere here, not necessarily the scale, somewhere here in the positive coordinate we can take 0.85. So since it is z greater than 0.85, I can shade the region as shown in the figure. Okay, now my aim is to get my 0.85 to infinity, that we have to calculate, that's our aim. So how we can calculate that? Say I can take from 0 to infinity, means I can consider the region from 0 to infinity. In that one, I'm going to subtract this part. I'm going to subtract this part. I'm going to consider the entire right side. In that one, I'm going to remove from 0 to 0.85. The remaining region will be greater than 0.85. So that's what we have taken here. If you observe, see, to calculate p of z greater than 0.85, so I have taken p of z greater than or equal to 0. From there, I am lessing 0 to z, z to 0.85. See, as we have earlier discussed, the bell-shaped curve, the right-hand side of the curve is always 0.5. So that's what I have taken 0.5 minus. See, as in the note, z less than z1 can be written as, so phi of 0.85. See, this 0.5 I kept as it is, and phi of 0.85, if you calculate this from normal distribution table or from calci also you can calculate, this one is 0.3023. As you know how you are going to, at the end of the video, I'm going to explain you people how you can get 0.3023. If you subtract this, you're going to get the same. Now, second problem, we have to calculate P of Z less than minus 0.243. Now again I'm going to consider the bell-shaped curve. See, what I have to calculate here is Z less than minus 2.43. So somewhere I'm going to take in the left side, since it's a negative quadrant, I'm going to take minus 2.43. Since it is less than that, so I have to take this one. So this is the shape that we have taken. See, from here to here. Now, since the symmetry means this bell-shaped curve exactly divide this line by 2. So this region is same as 2.43 and above. Correct? Say from minus 2.43 onwards and 2.43 onwards, it's same. So we can tell P of Z less than minus 2.43 is same as P of Z greater than 2.43. Okay, so that's what here we have taken. P of Z less than minus 2.43 is same as P of Z greater than 2.43. Now this can be written as P of Z greater than 0 minus P of Z less than 2.43, as we discussed in the previous problem. See, my aim is to get Z greater than 2.43, means this region. Okay. Now how can you calculate this? Consider from 0 to infinity. In that one, we can remove this region. Okay. This one, as I've told here. See, this one I'm removing. See, once you remove that, you can get 0.5 minus phi of 2.43. So you can calculate this phi of 2.43 using your calci or from normal distribution table. You are going to get the value 0.4925. If you do that, you are going to get the answer. Now when you come for the third problem, see, they are asking us to get Z lies between minus 1.64 to minus 0.88. Okay. Now in the bell-shaped curve, if I want to just go for that one, see here Z we have taken minus 1.64 to minus 1.088. Okay, means we have to calculate this region, the shaded region which we have taken. This region we have to calculate. Correct? Because of the symmetry, I can write down this in the positive octant like this. See here, Z lies between minus 1.64 to 0.88. Now here in the positive octant, the same thing can be written as Z lies between 0.88 to 1.64. Correct? So I can write down this as P of 0.88 is less than Z less than 1.64. I can write this as, say, 0 to 1.644 minus this. Means what? It's very simple. I want to get from here to here. So what I'm going to do, from 0 to 1.64 I'm going to take. What I'm going to consider, from 0 to 1.64 I'm going to consider. From there I'm going to subtract 0 to 0.88. I have taken 0 to 1.64. In that one, I am subtracting 0 to 0.88. Then definitely I am going to get 0.88 to 1.64. That's what we have done here. So we can get either side phi of 1.64 minus phi of 0.88. So both the things can be calculated either from normal distribution table or from your calci, and you're going to get these two values, and from there you can easily get the answer. Okay. Now I can concentrate the next problem. Okay. Now here I can calculate X is the normal variate with mean 30 that given and standard deviation is 5. Find the probability that X lies between 26 to 40 that given. Now here that given mu that we have taken, that given mu, what that given, mu 30. Mean 30 that given, standard deviation that given, that is sigma is equal to 5. So we have it as mu, we have it as sigma. So we can easily calculate the standard normal variate. What is standard normal variate? It is z is equal to x minus mu divided by sigma. So mu is given, sigma is given. I'm going to take x is equal to x minus 30 divided by 5 as I have taken here. Now I'll come for the first sub question. Now I have to find p of 26 less than or equal to x less than or equal to 40. Now I should calculate this in terms of z. How? See, first I have to calculate what will be the z value when x is equal to 26 and what will be the z value when x is equal to 40. That's what we are doing it. So when x is equal to 26, my z will be minus 0.8. So you may think how we got this. Substitute this x here in this equation. So it will become 26 minus 30 divided by 5. If you do that, you are going to get z is equal to minus 0.8. Same thing, substitute this x is equal to 40 here in this formula. So it becomes 40 minus 30 divided by 5. And if you simplify that, you are going to get z is equal to 2. Now writing p of x lies between 26 and 40 is same as p lies between p of z lies between minus 0.8 to 2. That's equal to, see, we can write down this as minus 0.8 to 0 one part plus 0 to 2 another part, as we have discussed in the bell-shaped curve. See here, I need minus 0.8 to 2, correct? So how we can get that? First I am going to consider from minus 0.8 to 0, correct? And from 0 to 2. So I have to calculate both. If I calculate together, then I can easily find out the area from minus 0.8 to 2. Now this can be written as, see, as I have told already, 0.8 to 0 and 0 to 0.2. That's what we have done here. Now this can be written as 0 to 0.8 and 0 to 2 because of the symmetry. This one we have got because of the symmetry, correct? So this can be written as phi of 0.8 and this can be written as phi of 2. I told already these two can be obtained either from normal distribution table or from your calc. Directly you can calculate, and if you simplify, you are going to get this answer. Now second sub question in the same, if you go, so I have to calculate p of x greater than or equal to 45. So now I should convert it in terms of z, or I have to write it this in terms of z. How can we calculate z? It's very simple. Substitute this x is equal to 45 in standard normal variate. That is z is equal to x minus mu by sigma. I think z is equal to x minus 30 divided by 5. Now if you substitute there 45, you're going to get z is 3. So writing p of x greater than or equal to 45 is same as writing p of z greater than or equal to 3. And that can be written as p of z greater than 0 minus p of z less than 3, as we have shown in the figure. See, I have to calculate p of z greater than or equal to 3. Means from here to here. This part I have to calculate, correct? So how can I calculate? So I can get from here, okay? I can take this is 0, okay? From here, I can consider the entire right side, and from there, I am going to remove from 0 to 3. So from the entire half side, if I remove from 0 to 3, I will get the region which is greater than 3. That's what we have done here. So entire half side, you can write it as 0.5 minus this can be z less than z1, can be written as phi of z1, that is phi of 3. No, we know we can calculate this either from normal distribution table or from calc directly. So if you simplify, you're going to get this as the answer. Now, so I can go for some other kind of problems. See, x is normally distributed with mean 12 and standard deviation 4. They had given. Means what? Again, if you want to write, they had given mu. What is that? 12 they had given. Mean, okay? And also they had given standard deviation. What's that? 4. Okay, now once we know mu and sigma, it is very easy for us to get standard normal variate. The formula for that already we know, that z is equal to x minus mu divided by sigma, that's equal to x minus 12, because mu is 12 and sigma is 4, that I'm going to write it here, correct? So now first sub question, if you concentrate, we have to calculate p of x greater than 20. Correct? Now if you convert this to z, first you have to get what will be the value of z when x is 20. When you substitute this x is equal to 20 in this normal standard variate, you can get z is equal to 2. Now writing p of x greater than or equal to 20 is same as p of z greater than or equal to 2. That's equal to, now how can you get this? So you first get the entire right hand side of the line, that is p of z greater than or equal to 0. From there we are going to remove p of z less than 2. Now if you go through the bell shaped curve, then it will be clear. Actually we have to calculate from this one, means 2 onward. This is 2. Okay, from here to this entire region we have to calculate. How can we do that? First from 0, okay, I'll consider this entire region. Okay, from there I'm going to remove this part. Okay, once you remove this part in the entire half, then you are going to get from here to there, correct? That's what we have done here. This is p of z greater than or equal to 0 minus p of z less than or equal to 2. Now p of z greater than or equal to 0 means what? The entire half side, and it will be 0.5 minus this is p of z less than z1 form, so you can write that as phi of 2. So as you know, we can calculate this either from normal distribution table or directly from the calc. So you're going to get this much. If you simplify, you're going to get this. Now if you concentrate the second sub question, you should calculate what is z when x is equal to 20. That already we have taken, that is 2. Now writing p of x less than or equal to 20 is same as writing p of z is less than or equal to 2. Okay, this can be obtained in this format as we have shown in the figure. So it is what exactly that we have to calculate? Less than or equal to 2. Less than or equal to 2 means what? It is not restricted less than or equal to 2 to 0. So it is just less than or equal to 2 means what? It is from 2 to up to minus infinity. Correct? So less than or equal to 2 means what? From 2 to minus infinity. So that's what I have shaded all the region over here. Correct? Now how can I calculate? So this entire region can be partitioned into two parts. How? From minus infinity to 0 is the first part. See that we have taken minus infinity less than or equal to z less than or equal to 0, and then from 0 to 2 that we have taken. So this entire thing I have to calculate. So I have splitted this into two parts. That's what we have taken here. Minus infinity to 0 plus 0 to 2. Now minus infinity to 0 means the entire left side, and obviously that is 0.5 plus this is z less than z1 form. I can write that as phi of 2. Now I can write phi of 2 by using normal distribution table or calc as we have already discussed. So I can simplify. I'm going to get this. So everything from bell shaped curve, I think you can easily evaluate the things. It will be easy for us to solve the problems. Okay. Next one, it's kind wordings type of problems that we'll concentrate. The problem is the marks of 1,000 students in an examination, okay, follows a normal distribution. They had given that as normal distribution with mean 70 and standard deviation 5. Okay, find the number of students whose marks will be less than 65, more than 75, between 65 and 75. Correct? Now first I have to consider x. Okay, that x what I have taken. Okay, x represents the marks of the students. Okay, now I will take the given data. They had given mean of the distribution is 70 in the problem itself, directly they had given, and standard deviation they had given, that is sigma. I have taken that also here. Fine. correct? We have with us mu, we have with us sigma. It is very easy for us to go with standard normal variate, that is z is equal to x minus mu by sigma, and we can write that, and we can substitute mu as 70 and sigma as 5 because that they had given. Now we can calculate z when x is equal to 65 because we are going to convert that to z in terms of z. So first we'll calculate what will be the value of z when x is equal to 65 for the first sub question I'm talking with. Okay, now when x is equal to 65, so I'll get z is equal to minus 1. Again, if we have any doubts, any one, see this 65, x is equal to 65, I'm going to substitute here. So it is 65 minus 70 divided by 5. If you do, then you're going to get z is equal to minus 1. And hence, writing p of x less than 65 is same as writing p of z less than minus 1. So for the first sub question, we need to calculate p of z less than minus 1. Now, how can you write that? Because of the symmetry of the curve, we can write p of z less than minus 1 as p of z greater than 1. As we have taken it in the figure, actually we have to calculate that from minus infinity and less than that, correct? Because of the symmetry, from here to here is same as from 1 to infinity. So instead of this, better we can calculate this. So that's what we have taken, p of z greater than 1. As usual, to calculate p of z greater than 1, first I will consider entire right side of the curve, that is z greater than or equal to 0. From there, I am going to subtract from 0 to 1, that is this area. Okay, so this one 0 to 1. So first I'll consider from 0 to infinity. From there, I'm going to subtract this area. Okay, so if you subtract that, then from here to here I'm going to get, that's what we have taken. So entire right hand side of the curve is 0.5, and this is z less than z1 can be written as pi of 1. So we can calculate this from normal distribution table or from the calc. So if you simplify, you're going to get this one. So now I can't stop here itself because they're asking number of students who got marks less than 65. Now this gives the probability. Now I should multiply this with the 1000 students because the entire problem is based on 1000 students. So if you multiply that with 1000, you are going to get 158.7. So I have to round it up that because students cannot be put up that in decimal. So I can round up that to 159 students. So we can conclude that 159 students have got marks less than 65. Correct? Now we can concentrate the second one. So second one says what? The number of students out of 1000 who got marks more than 75. Correct? So first, to calculate that, I should calculate what is my z when x is equal to 75. Okay, I have to calculate what is that. I have to calculate 75. I think it's wrong. You have to take 75 over there. Now if you simplify that, you are going to get z is equal to 3, it's same. Now how can you calculate p of z greater than or equal to 3? Again, entire right side. From there you are going to calculate from 0 to 3. Now if you do that, you are going to get this. As usual, you can calculate all this thing from either normal distribution table or from the calc sheet directly. So you are going to get 0.0013 or something. Now if you do that, I can't stop it there itself because I have to calculate the number of students. So since we are talking about the number of students is 1000, I can multiply that point something what I've got. So with 1000 I can get 158.7. So that also can be written as 159. Correct? And the third one, I have to calculate the number of students who got marks between 65 and 75. Between 65 and 75. See, between 65, z is minus 1, which we have already calculated. 75 means it's 1. Okay. Now, means I have to calculate now. Z lies between minus 1 and 1. So, this is same as writing 2 times p of z lies between 0 to 1. I think if I want to go with the figure, so I can go like this. See, this is I can write it phi of z, and this one I can write it z. Okay, now I can take a bell-shaped curve. Okay, it will be like this. Now I have to calculate some way here from -1 and some way here to 1. See, I have to calculate this entire thing actually for that particular problem, correct? Because it is from -1 to 1. So I have taken -1 to 1. So what we are discussing here, instead of calculating this entire thing, now see, this is symmetry. This curve is symmetrical about 5z. Now, from 0 to -1 is same as 0 to 1. Correct? So, since I have to calculate from -1 to 1, what I can do, so instead of going from here to here, I can calculate this distance, means 0 to 1, and I'm going to multiply that with 2 because it is symmetry, and this 0 to 1 distance is same as 0 to -1. So calculate 0 to 1 and multiply that with 2. So that's what we have done there here. See, we can write -1 to 1 can be written as 2 times 0 to 1. So this 2 you can carry as it is, and 0 to 1 can be written as phi of 1. Again, you can calculate this either from normal distribution table or from the calci. You're going to get this much. So I have to multiply this with 1000 students because I should come to know the number of students who got marks between 65 and 75. So this is a probability of that one. So I can multiply this with 1000. So if you multiply that with 1000, you're going to get 682.6, and if you round up that, you're going to get 683. Means what? 683 students out of 1000 students will score marks between 65 and 75. Okay. Now, another problem, if you concentrate, in a test of an electric bulbs, it was found that the lifetime of the particular brand was distributed normally. They had given specifically it's a normal distribution with an average life of 2000 hours and standard deviation of 60 hours. If a firm purchases 2500 bulbs, find the number of bulbs that are likely to last for more than 2100 and less than 1950 hours, and between 1900 hours and 2100 hours, like that. See, as I've written in the problem, they had given mean time, that is mu is equal to 2000. Problem in the problem directly they had given, and standard deviation also they had given, sigma is equal to 60. So first step, what we have to do is getting standard normal variate, that is z is equal to x minus mu divided by sigma, and we can write x minus 2000 because mu is 2000 and sigma is 60, that we can take it. Now, first sub question, if you come for, so I have to calculate the number of bulbs likely to last more than 2100, means x greater than 2100. So if you want to convert this to z, so substitute this x is equal to 2100 in standard normal variate, you can get